You ready? So, taking what we did last day, the ability to label sides as opposite, adjacent, and hypotenuse, the ability to remember that sine is defined as the opposite side over the hypotenuse, that cosine is the adjacent over the hypotenuse, and that tangent is the opposite over the adjacent, and recognizing that our calculators have all this programmed in. Oh, here we go. So far we've learned how to name triangles. It says fill in the appropriate name in the blank. What I tend to do is, if I'm looking at a certain angle, I often color it in to make it stand out. Also because those of you that have had me before, I'm big on writing something down. I feel better just by coloring that in. I've increased the odds of success dramatically because my mental brain now is flowing. This side right here, is it opposite, adjacent, or hypotenuse? Nina is correct. Just put a lowercase h there. We're going to abbreviate. This side on the bottom, opposite or adjacent? It's adjacent. Now, if we were looking at this angle, it would be the opposite. But looking at this angle, it's adjacent. I'll put a little a there. And this one, all the way over here, opposite. We've also learned to find the sine or the cosine or the tangent. Or if you give me the sine or the cosine or the tangent, give me the angle. If you know the angle in degrees, you're not hitting the shift button or the second function button. So sine 35, I know it's going to be a little bit bigger than 0.5. What is the sine 35? And give it to me to 3 decimal places. 0.574? Is that right? Rounded off properly? Yeah, okay. Cosine of 15, was it 0.866? No, 0.966? I remembered that because we did it last class and I taught the same lesson 3 times. I don't have that one memorized, but right now it's there. What's the difference between C and A and B? In C, we're finding an angle. This is going to be the shift or the second function button. So now I'm going to go second function tan of 3.145. And the angle that came from was 72 degrees. When I'm finding an angle, people ask me, Mr. Dueck, how accurate do you want to be? I usually go to the nearest degree. And the reason is 1 degree is only about this big. It's very small. 0.1 of a degree, Lachlan, I don't know if the human eye can even detect that small a difference. So you can go to 1 decimal place if you want to, and I'm not going to take marks off, but you'll notice in my answer keys, typically I go to the nearest degree. Now we're going to solve for a missing side or a missing angle. And to do this, there are 3 steps. We label opposite, adjacent, hypotenuse. We figure out the ratio using SOHCAHTOA. And you've just written that on the page. Had we not done that, my next step before I got to example 1, I would have said to you, somewhere on the top of your page, write down SOHCAHTOA, but now we've got it there. And then we solve, and I'm going to leave that blank. Here's how we're going to do this then. Maddie, this is meant to be stupidly obvious. Example 1, what shape is this? And more specifically, it's a right-angled triangle. There is also non-right-angled trig, and I'm not going to teach you that this year. Normally I would, but since I'm doing trig from scratch, I don't have time. What do they want me to find? And this is also meant to be fairly Captain Obvious. X. Okay? What angle did they give me in degrees? How big? Yep, we're being really obvious. So everybody right now, color that in. Okay. Do you notice, Maddie, that one side is completely blank? Has nothing on it? Ignore it. Some teachers teach kids to label everything, all 3 sides always. I think that's a waste of effort and it makes it more confusing. We're going to label the 2 sides that have stuff on them. That 15, folks, opposite, adjacent, or hypotenuse. Put an A there. That X, opposite or adjacent. Put an O there. Maddie, which 2 letters have I written down? Which trig function has the O and the A in it? Look at the SOHCAHTOA word. What you were doing this summer? What always goes next to the trig function? The angle. What always goes next to the trig function? The angle. What always goes next to the trig function? Everybody? I'm doing that for a reason. What's the angle here, Maddie? Yep. Equals opposite, except I'm not going to write O. What's the opposite side labeled as? Over. What's the adjacent side labeled as? Maddie, how would I get the x by itself? I'm perfectly fine if you go straight to the answer now, and if that's the only line of work you show. In fact, I'd kind of like you to get there. I'm not only perfectly fine, I'm strongly encouraging that if you can solve trig with one line, better yet, if you can reach the point where you can solve trig with no line, but one line is pretty good. We are going to get 15, 10, 18, 4.87. That also looks right roughly with the scale of that triangle, because that small angle is about 18 degrees, and it would definitely be shorter than the 15. So 4.873. I'll go to 3 sig figs, 4.87. Did they give me any units? No? Okay. Repeat. Here we go. Jolene, what angle did they give me? Do you see it? I'm going to color it in. Can you see one side is blank? By the way, the reason I always leave the one side blank that is blank, if I had just automatically put the H there, can you see, Maddie, now you're having to pick from 3 letters, which is more confusing. Why not leave that blank and then it's obvious, it's tangent. If you put the H there, you've done extra work, and now in your mind you're crossing out the H and ignoring it. Well, then why not just not write it in the first place? Jolene, that X, opposite, adjacent, or hypotenuse? Let's put an H there. What about that 3? I have A and H. Ah! Which trig function is that? What always goes next to the trig function? What's the angle here? And that's going to equal what over what? I know it's adjacent over hypotenuse, but more specific for this triangle, what over what? What over what? Yes. Jolene, how is this X different from Maddie's? Where is the X in B? No, it's not. Same question, yes? How would I get the X by itself? Okay, if you can go to this and go to the answer only writing one line down like this, again, Lachlan, I'm fine with that. In fact, I kind of encourage that. I want you to get so good at trig that it's boring. If trig is the stumbling block, then we're in trouble. I want the physics to be the challenge, not the math. So it's going to be 3 divided by cos 56. You get 5.366, and that also looks right with the scale because the X is the hypotenuse and it should definitely be bigger than the 3, so I'm okay with that. So 5.36. Next page over. Will, what angle did they give me? They didn't give me a number, they gave me a Greek letter, but what Greek letter is that? Do you remember? Alpha. Let's color it in. There are 2 sides that are labeled. One side is blank, so I'm going to leave the blank one blank. That 11, opposite, adjacent, or hypotenuse? I agree. What about that 12? I agree. O and H, which trig function? Sin is when you swear in my class or when you show up late. The trig function isn't sin. Sine. Are you ready, folks? What always goes next to the trig function? What did I tell you? What's the angle here as a variable? Okay. Equals, sine is opposite over hypotenuse. What's the opposite side here? Over. What am I finding here? I'm finding an angle. Oh, how do I find an angle? How do I go backwards on my calculator? Yeah, someone said it. I heard it whispered there. Second function or shift or whatever. Now, all of you follow along. We're going to have to use some brackets here. So you're going to go second function sine, and you have to open a bracket because we want to put 11 over 12. That's what we're taking the reverse, the inverse sine, the arc sine of. If you don't open a bracket, it'll just go shift sine of 11 and freak out. So you have to put the 11 over 12 in brackets. And the angle originally was 66.4 degrees. I'd take 66. I'll go to one decimal place just for giggles, but... And you can see, William, I almost did nothing new there. I did the same procedure as Maddie and Jolene did. Color the angle in just because I feel better. Label the sides. What always goes next to the trig function, the angle. If they didn't give it to you, put the variable there. And then you have to decide, is the x not an angle? I can use grade 8-9 algebra. Oh, the x is inside the sine or the cosine, or it's an angle. My calculator does it for me, which is actually less work. Still, no matter what, one line and we're good. Word problems. We're going to try some easy word problems. When doing word problems, remember, draw a little picture. Oh, and then I guess I can scribble out that picture there. Sorry. Gulp first. Then label ratios. Had to give you some terminology, though. In math and in physics, we talk about an angle of elevation and an angle of depression. Everybody right now, hold your non-writing hand straight out in front of your eyes, like this. Okay? Lachlan, you too. Alan, you too. Okay? Angle of elevation is from your eyes up. Go like that. Okay? Back straight again. So this is an angle of elevation. Okay? Angle of depression is from your eyes downwards. I always remember that because when you're depressed, your eyes go down because I'm so depressed. So there is an angle of depression. There is an angle of elevation. Okay? Example 5, an observer standing from a flagpole measures an angle of elevation of 63 degrees to the top of the pole. Find the height of the flagpole. This, when you go to Playland, is how you'll figure out how high the roller coaster is, or how high the elevator is, or how high the atmosphere. You'll need the heights to analyze the rides. They won't let you climb onto the ride and drop a tape measure. We'll use trig. What's the first thing I'm going to do here? Okay, and I know enough to know that there's going to be a triangle in there. There we go. What do they want me to find? Jacqueline, what do they want me to find? I'm pretty sure that means that's the x. You okay with that? 3.5 meters away from a flagpole. Is that 3.5 going to go there, or is that 3.5 going to go there? I think along the base. So the person is standing right here. Angle of elevation is from your eyes up, so it's this angle here is 63 degrees. Dylan, that x opposite adjacent to hypotenuse. What about that 3.5? Which trig function? What always goes next to the trig function? And that's going to equal opposite over adjacent. How would I get the x by itself, Dylan? Okay. My scale is clearly terrible. The x should be longer than the 3.5. Oh yeah, because 63 degrees is pretty steep. It's about like that. And I drew a wonky angle, so I could have probably drawn a better picture, but whatever. 6.87? Meters. So if you measure the angle to the top of a ride at Playland, and if you know how far away you're standing from the ride, and we'll give you clever ways to figure that out as well, you can figure out how high the ride is. A kite is flown with 210 meters of string. The angle of elevation of the kite is 61 degrees. How high is the kite? Mr. Dueck, isn't this exactly the same question? I don't know. Johnny, what are they asking me to find? I think that's going to go there. Where's that 210 meters of string going to go? Yeah. I've learned I now need to ask this question because you grew up in a different time from me. So I will ask. How many of you have never flown a kite? Just one? The rest of you have flown a kite? You flew a kite this... It's fun. A few years ago, I was in Bellingham walking along the waterfront, and on Thursdays, there's a kite club that shows up there. And so there was an elder gentleman who had made a series of kites. There was like 80 of them in a row that he slowly strung out, and he would leave them there, and we chatted for a bit. Kites are pretty cool. They also fly them by Vanier Park. You'll see them in Vancouver quite often as well. Angle of elevation from the eyes up. That's the angle of elevation. Aisha, that x opposite, adjacent, or hypotenuse. Oh, I usually color that in just so I know what I'm looking at. 210. Which trig function? What always goes next to the trig function? The angle equals x over 210. And you can use this, by the way, to figure out how high your kite is. If you're a kite flyer, you would actually have something, a device that measures how much string you've put out, and use a protractor to measure the angle of the kite. Oh, that's how high I am. It's a pretty trivial calculation. Times by 210, yes? You get 184 meters? Mr. Dueck is standing on an observation tower 30 meters above the ground. He sees Ryan standing 120 meters away from the base of the tower. Find the angle of depression. Mr. Dueck has to aim his Nerf dart gun in order to hit Ryan. Oh, I like this question. Let's add a little ambiance to it, shall we? Got my Nerf dart gun right here. Okay. Let's visualize. I guess there's going to be a triangle. This time, I think I'll put the tall part there because apparently Mr. Dueck is standing on a tower. Where's that 30 going to go? On the vertical or on the... Okay. Where's that 120 going to go? Here's the tricky part, folks. Where is the angle theta, the angle of depression, going to go? So remember I had you all stick your hands out. In my mind, I go straight out. That right there, and I usually use theta as my variable of choice for an angle, that's the angle of depression. By far the most common mistake, Johnny, kids want to put it there. Actually, it's not inside the triangle. That's a problem. Or is it? Let's find that angle. The one right next to it. I'll call it alpha. That 120, opposite, adjacent, or hypotenuse. To alpha, it's opposite. What about that 30? Adjacent. Which trig function? What always goes next to the trig function? The angle, and the angle I'm looking at right now is angle alpha. Equals 120 over 30. How do I find an angle? Now you remember. Good. So shift tan, bracket, Mine automatically opens a bracket. Your calculator might not, but you got to put it in brackets. 120 divided by 30, close bracket. Angle alpha is 75.96. You know what? It's 76 degrees. How does that help me figure out how big theta is? Do you see it? Yeah. Yeah. These two add to 90. There's a fancy word for that. They're complementary. If angles add to 90, we call them complementary. So, if that one there is 76 degrees, how big is angle theta? Now, in our notes, let's write down what we did. So let's write down theta equals 90 minus 76, which is 14 degrees. If you didn't show that step in your homework, if you went straight to saying the answer, I'm fine with that. But yeah, we got to jump around a little bit. Now, other patterns to notice. How big is this angle right here? Angle alpha, 76. How big is this angle? How big is this angle? 14. So this angle and this angle are the same. The other thing you could have done as a shortcut if you wanted to get there in one step is you could have said, you know what? That's also angle theta, and you could have just solved for that directly without having to go 90 minus. There's lots of patterns here. Victor, choose which you're happier with. Turn the page. Skip number 1, do number 2. The instructions for my Math 10 say label the size, write the trig ratio, and solve. You know what? You can do that. Label the sides. You kind of have to. If you can do this in one line of writing just by writing down the trig equation and going straight to solving it, I'm fine with that. With grade 10s, I made them show a few extra steps because, you know, they're not quite as strong algebraically. So 2 is good. Word problems. I like 3A. I like 3B. 3C is good. D is good. E is good. E is using an angle of depression. Many of you will get this question wrong because you still haven't wrapped your brain around what's meant by angle of depression, but that's okay. That's why I'm giving it. And F. G, but skip H. I don't like the wording of H. Don't like the wording of I. I do like the wording of J. I did include the answers. There's really not much homework, but also I threw a lot at you yesterday, and some of you are still getting everything caught up. If you finish everything, great.